morning, madam. Madam, we'll, very good morning, everyone. I, Dr. Ravi Kumar, Head Department of Civil Engineering, welcome you all for this online two-day faculty development program on new generation construction materials and technologies. So before starting the program, kindly mute your mobiles, please, and let us begin this faculty development program with a prayer to seek the blessings of Almighty.
I said, Toma Satgamaya, Namai Soma Jyotirgamaya, Mrityurma Amritangamaya, Sarvijam Swaste Bhavatu, Sarvisham Shanti Bhavatu, Sarvesham Purnam Bhavatu, Sarvesham Mangalam Bhavatu, Loka Samasta Hino Bhavantu. Om Shanti Shanti Shanti.
Very good morning once again to everyone, to the faculty, distinguished participants. And thank you for registration for this program. The main objective of this faculty development program is to enrich the knowledge of faculties through interaction with eminent personalities from industries and academics. The knowledge sharing will improve the teaching learning process, which helps the students and benefit the society. Rapid urbanization and growing population require a sustainable construction sector and building materials to meet increasing high living standards while ensuring protecting the environment. The construction sector is crucial for economic growth as it accounts for 5 to 15% of the GDP and provides 5 to 10% of employment in our civil engineering constructions. So with this, our growing demands in the construction industry is continually contributing to the global environmental pollution at an alarming rate. With our ever-increasing global warming and exhaustion in conventional construction materials, the need of the hour is to come up with a new generation materials that would help us in saving this beautiful planet, our planet, and provide a sustainable solution to the industry. The new construction materials and technologies in saving this planet, new technologies that can be successfully incorporated in construction for a safe and sustainable living. And also, it is a step towards National Education Policy 2020, which focuses on multidisciplinary learning based curriculum with an introduction with various emerging technology courses in the V2 syllabus, such as smart materials and systems, green buildings, introduction to nanotechnology, etc. That will be having a last session tomorrow. As we had to go with the emerging technologies in our civil engineering, this program, FDP, is being planned. So, hence, in this regard, I look forward to the fruitful discussions and exchange the ideas today and tomorrow. Once again, I warmly welcome you all. Now, I request Mrs. Tamil Selvi to introduce the speaker of the first session.
Thank you so much, sir. Good morning, everyone. Myself, Tamil Selvi. I'm happy to introduce the speaker of today's session, Prabha M. She is currently working as assistant professor in NIT Trichy in civil engineering department. Our guest speaker today we are going to see is very simple, energetic, and dynamic in person. And she finished her BE in Tyagarajar College of Engineering and ME in structural engineering at Anna University. There she owns a gold medal and university rank in the Department of Structural Engineering. She specialized her PhD in building technology and construction management in the renowned institution IIT Madras. That she owns All-Round Performance Award for demonstrating good academic performance, leadership in extracurricular and co-curricular activities at the department level and also divisional levels. So, with respect to the PhD, she also owns a poster award in ACA Concrete USA, Salt City, in the year 2018. So, she got research fellowship also by MHRD, Central Government of India, which is remarkable. So, she started her journey first as a project associate in the Department of Civil Engineering, IIT Madras, and she climbed up to senior project officer in the same renowned remarkable. And after she started her teaching journey in NIT Trichy, she is working still now. So she delivered many lectures in Larsen Tubro, IIT Madras, Tyagarajar Engineering College, her own institution. So she is very well known for her work, and she has a lot of passion for teaching. She is guiding many research scholars as well, and MTech, BTech students also, various levels she is guiding it. And she published various journals, very reputed journals in construction materials domain. So now I welcome the speaker. Thank you so much, ma'am, for joining. And please enlighten us in the field of new generation construction materials and technology limited. And especially today's title is about roles of materials in modern construction practices. I welcome you, ma'am, warmly. I welcome everyone. Thank you so much for joining.
Thank you so much. Thank you so much for the warm introduction. Yeah. So shall we start?
Yes, madam. Please, madam.
So let me share my screen. Is my screen visible to you all?
Yes, ma'am.
Yeah. So very good morning to everyone. And today, I know you all are going to have next 2 days for this faculty development program, focusing mainly on the construction materials and then their aspects for achieving sustainability, right? So mine is going to be the very first lecture for you. So I'll just briefly give an introduction about the general construction materials that we have in field and how we can focus on the performance to enhance the requirement or to meet the serviceability demand. Right? What is sustainability in general? So anything that requires or that consumes less energy by that consumes less energy or that works with sufficient energy without spending additional energy. So basically we need to conserve our resources and the energy involved in it, and then the materials, everything in and around. That's what we call it a circular economy. So that's why we try to work to meet the sustainability demand, so that we don't need to spend unnecessarily our resources as well as the energy and cost time involved in it. That's why we give a lot of emphasis for the sustainability construction. And when we talk about the structures, without materials, because materials are the ingredients that you are going to put in your structure to meet the required performance, right? Or the structural requirements. So that's why we give a lot of importance to materials also, how this is going to govern the performance of the structure, right? So if the ingredient is not good, you cannot achieve the required performance. So that's why we need to understand the behavior of the structures from the material level. So the very first lecture is going to be focusing on the role of materials in modern constructions for meeting sustainability demand. And you can see here I have just included two representative images to highlight the need for the construction demand in our country, and how well we have to drive the importance to sustainability, and then the connecting the behavior from the material level to the structures. So the very first image that what is it? This is a signature image of the Mumbai Mandravali bridge. Here you have, and then this image, this basically indicates the mass housing. So in our nation, so we have a lot of schemes in the ministry. So one of the scheme is that housing for all. So we have going to have the mass constructions in the upcoming years. So the construction growth and the demand for the upcoming system tremendous, especially when you look at the infrastructure projects, or if you look at the mass housing projects and so on. So for anything to achieve the requirements, so you need to choose the right materials. So you need to be knowing how to choose the right materials with the required performance, because you will be using the materials without knowing the performance of it. So unless the material is examined, you will not be known what quality of the material that you are going to be using. So though that tells you that the material is having certain well required parameters, you need to qualify it, you need to test it, and then you need to examine, okay, this material is satisfying the requirements and it can be purchased. Fortunately, many materials that we have in the practice are not meeting the required conditions. The quality control is very poor in the manufacturing industry, especially when we have secondary or secondary player manufacturers. So they may not give emphasis to the quality. That is because they may not know the importance of the quality, how it is going to affect. So the presentation is overall is going to highlight the material properties, and then the testing methods that is required to identify the good quality material. Basically, when focusing on concrete as well as for the steel, because for any construction material system that we have, we are basically focusing on reinforced concrete structures or the pre-stressed concrete structures. In both cases you'll be having concrete as well as steel. So the material to work together, they should have good compatibility. How do we ensure good compatibility? We'll be checking the bond between the concrete and the reinforcement, right? So I'll touch all these aspects in this presentation, and then we'll get into it. So the general outline of the presentation is this. So first I'll be explaining about the importance and role of materials in general for any concrete structures, and then challenges that we have in meeting the required performance. And when we look at the advanced concrete systems, these are the various technologies that we can wrapped in the system. So likewise, pre-stressed concrete, a self-healing concrete, or 3D printing concrete. So 3D printing concrete is very tough the topic. And then you really in India we have a lot of scope for 3D printing concrete in upcoming future, and IIT Madras is exclusively working on this 3D printing concrete concept, and there is one startup under IIT Madras. They are doing tremendous work on this 3D printing concrete. And then significance of reinforcement, how the reinforcement has to be examined, and then the importance of the parameters that we look for the reinforcement will be touched, and then the summary of the whole presentation will be given. So in the title slide, I was just emphasizing why we need to worry about the sustainability, and then the role of materials which will help us to achieve the sustainability. This here you can see. So this just summarized that India is of course witnessing a huge construction boom. So we have a lot of scope for the highways, seaports, and airports projects, because you all know that we have huge marine area, sea area. So we need to have the constructions around it. So we know, and then we have residential and commercial buildings, and we have project urban and rural projects. So connecting urban and rural project is also one of the scheme under this. So all these things we have huge, materials involved, and then the construction practices that is going to be adapted to enhance the performance of the structure need to be sensitized. So we need to keep them safe and unusable for longer periods. So that basically touches the serviceability of your structure. So we generally construct these structures to serve for 100 plus years. Unfortunately, many of the structures tend to show early deterioration signs within 10 or 15 years of its construction. So you might be observed some cracks, and then if you are not addressing the cracks at the earlier stage, so that will cause severe durability issues in the structures, and that is going to influence your serviceability of the structure. So that's why we need to keep our structures safe and usable for longer durations without much maintenance and repair, because when you do maintenance, then it is going to be a periodical thing. You need to do it periodically, and then the cost and time involved for that no, maintenance is something that you examine and ensure that the structure is well performing. So if you do frequent maintenance, you can easily identify the issues at the early stage itself. If you're not doing the maintenance, then you may end up in a huge repair work. So that's why whenever you do construct the structures, we always prefer to do a construction such a way that it should not need any such maintenance or repair work at frequent cycles. So what is the scenario today? So for example, this basically gives you the some of the data I have sourced from Professor Pillai and Gitu's course content in IIT Madras. So here it was mentioned that we have survived about 1.7 lakhs bridges in India. So under the program of Indian Bridge Management System, Ministry of Road Transport and Highways, Government of India. So among that, we found out that 6,000 bridges are structurally distressed, and many of the structures are, partially distressed conditions. And this is the data that we got it for this particular lakhs. But there are a number of bridges which were not accounted. So in that case, this number may become, alarming. Significantly high. So actually, this much even more because the database itself are inadequate, and it could be incomplete also. If this is the case for the bridges, just think about the building. So we really give least importance to the buildings that we have in our or in and around surroundings, right? We just construct the building. After that, unless the owner gives an importance, the buildings will be taken care, else it will be left as it is. So the point to notice that we have a Herculean task of maintaining the existing concrete infrastructures as well as building new ones with required durability and corrosion resistance in consideration. Why I say corrosion resistance? For many of the durability issues, corrosion is the huge corrosion plays a huge role in terms of affecting the performance, right? So I'm just highlighting here the importance of concrete systems. Why do we need to worry about in terms of corrosion? Because the corrosion consumes a lot of money, because we deal with the concrete structures with respect to steel reinforcement, right? If you observe a slight crack, and that crack is going to allow external or foreign elements to get into your matrix. So if the moisture is increasing, if the air is increasing, that is going to eventually reach the surface level of your reinforcement. And once your reinforcement is in contact with the moisture and air, that is going to react in the sense that is going to start initiating the corrosion. So you tend to observe lot of cracks with stain marks. So you might have been observed in many of these structures. If the crack is there, and if it is going to be continuously there without repairing it, and that is going to get go deeper and deeper to reach the steel surface, and it is going to start corroding, and you say that you see the lot of rust formations or stains on the concrete surface. So this, the one report says, this is about 3 to 5 percentage of nation's GDP in some countries, and even it could be up to 50 percentage of construction budgets. So why do we have such scenario? Because the existing knowledge is not adequately applied when you do the construction work. So what we study or what we theoretically know, that is not being properly implemented at the construction site. So that's why we see this huge gap between what we know about the materials, but what actually behaves in the concrete construction site. Or once the structure is constructed and it is going to be exposed to various um, conditions, that could be environmental conditions, or that could be loading conditions, serviceability conditions. So let us look at how the different conditions would induce problems in reinforced concrete members. And here you can see it's a concrete. It's just for your understanding, you can see this whole element as the concrete, and then inside you have a rebar. And generally, when we talk about the concrete, we divide the concrete regions into two categories. One is about the covercrete, that is the region which is going to protect your steel rebar. Another one is corecrete. So what we tell is this as covercrete, and this is going to be the corecrete. So covercrete is responsible for durability, and whereas the corecrete is responsible for the strength. This is responsible for durability, and this is responsible for strength. All right. So the purpose of having covercrete is to protect your rebar, and if the quality of covercrete is not adequate, then it is not going to serve its purpose. So that's why, in general, the code specifies you to have a minimal covercrete of this much, depending on the environmental condition where your structure is going to be constructed, right? So might be knowing it 25 mm or 30 mm, 40 mm, 50 mm, or even you can go up to 75 mm if the severity is higher. So the idea is the concrete covercrete. Here it is typically mentioned as cover concrete, and here you have it is mentioned as bulk concrete instead of core. All right. So the concrete mostly we give least importance. We will not use good quality concrete, or we will not be providing adequate amount of cover depth. So some cases you might be seeing that the rebar itself will be visible because the concrete is not provided or placed adequate enough depth. So once the outer layer of the concrete that is present, or even the mortar that causes a peel off, you can barely see the rebar, right? So we are not unaware of the role of cover crate to protect your steel. Why? Because cover crate or the regions which are going to be subjected to different environmental conditions, you can see the drying at surface will occur on the cover crate, or you can see if something is getting increased. First, it will be in contact with your cover crate, and then it will slowly get penetrate into your concrete to reach your steel. So if you have poor quality near surface concrete, and this is going to be easily lose its moisture, and it also, when it gets chance, it is going to allow the foreign elements, that is other outside elements, to get into your concrete matrix, right? So typically you'll be having a good quality interior concrete, but generally the outer concrete will be in poor nature. So you have to give enough importance to the concrete as well to enhance its performance. So the for sustainable structures, good quality of matter material should be used. So the concrete should also be in good quality as equal to your core grade. So what is the durability that we are talking about? So when you have a concrete system, so we typically divide the concrete systems into two categories. One is about the materials, another one is about the process in which it is being made. So when you talk about the material, you are very much aware of how the concrete is being prepared. So you'll be having a binder type, and you'll have some binder content that could be, the cement, and then it has to be placed. So we are not equipping our workers to be knowing about what the person is doing. So is my voice is audible?
Yes, ma'am, you are audible.
Okay, so yeah. So we are not equipping the person for the work he is doing. So inside you might be noticed that if the worker feels that the water or the concreting is not good enough, what he'll do, he'll just pour 1 cup of water and just mix it and place it, right? So the mix design will change when the worker does something like that, or the cement may be used in a very less quantity. So all those things is going to be affect the structure. And in case if you're designing for M30, and actually it will be some M10 or M15 on the construction, so there are some something that we cannot have in our control, because we need, those are something that we need to train the workers who are going to. So screen is not shared. Hello,
Yeah,
can
ma'am.
you see the screen?
No, ma'am, the screen is not visible.
This is how it was from the first.
No, no, only after rejoining.
No, I did not do anything.
Okay. Can you share it again, ma'am?
Yeah, I'll share it again.
Yeah, ma'am, it is visible.
Alright. So that's all with the concrete systems that we deal with respect to materials or the process. And when we look at the aggressiveness of the environment, right? So we can categorize that into two times. So one is with respect to the physical attack, or another one is with respect to chemical attack. When we talk about physical attack, the abrasion, erosion, cavitation, or freeze thaw, all those things going to influence your concrete. When you talk about the chemical, so this is about what type of chemical is in contact with your concrete and how it is going to react with the ingredients that you have in your concrete to lead the damages. So this is associated with dissolution, leaching, expansion, alteration. Okay. So just to brief in general about the concrete systems, you have a concrete, and then you'll be having concretes or basically your lot of materials combined, right? It's a highly heterogeneous materials. You'll be having a cement, you'll a cement materials that you have in your concrete. You have fine aggregates, coarse aggregates, water, right? So this is not a homogeneous material. So you have all the materials put together and bind together the binder, and thus you'll be having a lot of pores in it. So the pores, the connected pores, that what it is going to permeate the foreign elements to get into your concrete. That is what we call it as permeability. So permeability basically represents the connectivity between your pores. So it is but you can prepare a concrete without interconnectivity. So the pores can be present in the concrete, but the pores connectivity should not be there. If it is connected, then it gives a direct path, so that can easily penetrate into your concrete. Any material that wants to get
There is some internet issue. Kindly bear with us. The speaker will be rejoining in some time.
I sorry, I had a network issue. So I will just continue from where I stopped. So I have my screen is visible now. Okay. And
Yeah.
can you please tell me where did I got cut off? So we are discussing about the slide.
Yes, ma'am. Here.
Okay.
Permute.
Yes. So I was talking about the maybe I'll just turn off my video so that the bandwidth will be less to avoid some kind of internet issue. All right. Fine. So we're talking about concrete and then the pores and cracks, how that is going to influence. So you'll be having the connected pores that will result in permeability over the time. You may observe cracks, and then the formation of cracks will further help your pores to get connected. And if your concrete has a good permeability and if it has a lot of cracks and pores, then that is going to eventually allow chloride to ingress and oxygen to increase in it, and then salt water penetration. You may see carbonation getting to lead to carbonation reaction, and then saturation, water saturation would occur, and that will result in leaching. And in general, your concrete itself has some amount of alkali in cement and then silica in aggregates, and then depending on the exposure with respect to sulfate environment, or if the sulfate that you have already in your concrete, if it is not reacting when it has to be reacted, then over the time, especially when you are in steam curing, this is a scenario when the temperature is above 80 degrees Celsius, you are basically suppressing the sulfate reaction in the initial stage, and that is going to react at the later stage and result in delayed ringate formation, right? So when you have such combinations of oxygen ingress and saltwater penetration, or sometimes even carbonation, that is going to result in corrosion, or when you have the combination of water, alkali in cement, and silica in aggregate contact, that is going to result in alkali aggregate reaction. And if you have only these water saturations, or sometimes these could be in combinations also, so that may occur in hand together, and you may have bleaching, and if you have sulfate attack, that is basically going to result in concrete expansion, and thus going to crack your cover grid. So what is going to occur if it is cracking? Then it is going to, all this reaction is basically involved with expansion of your concrete material, and that is going to result in cracking, and you may lose the strength that has to be. So these are some common observations that we have with respect to the materials in concrete systems. Then let me talk about the common causes of deterioration of concrete. So what are the causes that would result in such scenario? Right. So you may have as I was telling, it could be due to sulfate attack, or physical or chemical attacks in form of abrasion or erosion. And you can see the percentage of these causes are listed here. So that could be due to abrasion or erosion, alkali aggregate reaction, and some amounts due to the chemical attack, and then the corrosion, carbonation corrosion. And here you have corrosion due to external chlorides, which is significant of about 33 percentage, and then corrosion due to inbuilt chlorides, that is about 5 percentage. How come this corrosion due to inbuilt chloride come? So that is about if you are using seawater. So
फोन मत निकलना
and then the importance of the cover crate. If you're not providing sufficient amount of cover crate, then that may result in low cover, and you will be having poor quality concrete, which is about 26 percentage. It's significantly high. And then poor design detailing, where the steel reinforcement plays a huge role. Why do we use steel reinforcement? Because your concrete is good in compression but poor in tension. So we place the steel to help your concrete. So the steel says, okay, you can stay cool. I can take some tension that is going to come. So that's how they work together. So that's why we provide steel. But if that steel detailing is not adequate enough, and that is not going to meet the required no purpose, so that's why the poor detailing would affect the concrete performance, and then poor workmanship, as I already explained how it is being done in the country. Wrong specifications, of course. The sometimes the codal practices that we have, it was developed in 1960s or 70s, and still we use the same codal practices with updated versions, but there is no much change in the specifications or the methods that we that is specified in the code. Why? Because the code specifications that is developed in 1960s were meant to meet the requirements for the materials available in those scenario, in those period. But now we have huge modern construction materials with significantly high strength parameters and other requirements. So in the same scenario, if we still use the specifications that is being developed in 1960s or 70s, that is not going to help. So we may think that could be conservative, but the over estimation that again influences the performance in various aspects. So I'll be touching about these codal specifications also in the latest presentation of the talk. And then failure of joints and waterproofing, because we all know connections or critical points in the structures, the joint has to be given proper care and it has to be waterproofed. If it is not, that is going to leak, and that is going to allow moisture to get into your concrete, and that's it. It is going to influence other issues. And wrong material choice selections. If you are asked to select a material, you have to choose a material in such a way that that is going to meet the required demand, right? So this is something that you have to govern when you are asked to choose the material selection. So you need to be knowing in and about the material, and then see whether that material would be, sometimes that material could be adequate enough for these applications, but there are certain materials that would be specifically designed for that application. So you need to be knowing what are the advanced materials available, especially for meeting that particular demand. So if you use it, then your design becomes so conservative with less effect. So I'll touch upon those aspects also as we move on. And this is the basic thing that I will be covering in this presentations. The balanced approach is what we look, especially to enhance the service life. So balanced approach in the sense, it is you give equal importance to your steel as well as your concrete, because your steel is going to help in taking the tension, and concrete is going to help in taking your compression, right? But steel, what is going to be going to protect your steel, that is cover grid, but we give least importance to the cover grid. So the point here is to notice that to protect your steel, you also need to give importance to your cover grid. You need to balance the quality of both, right? Balance the importance for both. So the steel with enhanced resistance against corrosion is the main thing to enhance the serviceability. Similarly, concrete covercrete with enhanced resistance against increase of deleterious elements is the other factors that is going to balance your synergetic effects to enhance the service life of your structure. So then, why concrete is a vital matter for any construction? Because now you may be thinking of replacement for anything, but we don't have any replacement for concrete till now. Why is it such a vital member for any construction? So just to highlight or sensitize the importance of concrete, I'll just brought a few plots from Zhang et al. So he was telling that annual production of concrete is significant tons per year, and the price is also very less compared to the other materials that we have in terms of metals, ceramics, or polymers. Steel, wood, bricks, and masonry. Your concrete lies somewhere here, right? The production is also high, the cost is also less. We still now we have not come up with some alternative which will serve the purpose better than our concrete with respect to its performance as well as the cost. And less, next thing, and we consider the energy. So when you talk about the sustainability, we talk on and around about the energy, right? The production energy involved in your material is also is very less compared to the other materials. So here you can see the energy involved in the various types of material ranging from aluminum to the aggregates. So concrete comes around in the range of 1.4 gigajoule per ton. So the amount of energy that you will be investing in preparing concrete is very less compared to the other type of materials. That's why concrete is such a vital matter for any construction. And here it gives says how the production of the cement has evolved over the decades. So ranging from 1990s to 2050, the prediction in various countries, especially the developed countries and then the developing countries, and focusing on India and China, where you have tremendous infrastructure growth in the coming years. So the cement demand in terms of billions tons, it is going to be very significantly high in India and China compared to other, the quantity of these two itself almost equal or greater than the quantity required in other developing countries, so some of other developing countries. So that means this something that sensitizes us to give more importance on the sustainability aspect. So when you are going to produce such huge cements, so we also need to come up with some ways in which we can save energies to meet the circular economy. So the concrete is the second highest consumed material. Why? Because it gives the desired properties for the good performance in terms of workability. When we talk about the workability, it deals about how much water you are going to add for the required strength, and how the admixtures could be helpful for enhancing the flowability of your moisture if the water content is less, especially for high strength materials, high strength concrete. So you may reduce the water content significantly. So the if as the water content reduces, your concrete becomes, the mix becomes too harsh. So the chemical admixtures will help you to achieve the flowability. And then compressive strength. So how do we ensure the compressive strength? By pore volumes. So as the pore volumes is lesser, so you will be having more denser structure, thus resulting in more compressive strength. And when you talk about the durability, that is governed by the connectivity between your pores. If the pores are connected, you will be having less durable material. If the pores are less connected, though the pore is more, but if you don't have the connectivity, then you will be achieving good durability. And then dimensional stability. So that is something that we look when you have huge surface area. Why? Because when those materials or those concrete is going to be exposed to the environmental conditions, right? So the humidity and the temperature which is going to be in the atmospheric condition is going to influence the performance in terms of shrinkage and that mechanism. So when the material is exposed in such a way, it should not lose its dimensional stability. So if the water content is huge, then when it is being exposed, or if the paste content is huge, then when it is being exposed, it tend to lose the, or the moisture on the surface level will get evaporate. That is what we call it as plastic shrinkage. And likewise, over the time, it would induce drying shrinkage, or thermal shrinkage, or autogeneous shrinkage if the water cement ratio is too low. And what is going to help in achieving the dimensional stability? Because in your concrete you will be having a cement and aggregates. Among these two, the cement is the one, cement and water is the one that that are prone to lose its dimensional stability. So the aggregates are too strong, and that will help you to achieve or enhance the stability better compared to the other material. So that's why we give importance to the efficient packing of granular materials. So when the exposure condition is inevitable for this shrinkage, then you choose your machine in such a way that it is not going to be lose its dimensional stability. So minimize the cement paste as much as possible and enhance the um, minimize the cement paste as much as possible and enhance the quantity of coarse aggregates, so that the dimensional stability will be well achieved. So when I talk about typical concrete systems we use in developing the infrastructure, when we talk about the concrete, we'll have normal concrete, and then normal concrete is a normal strength concrete, high performance concrete. ultra high performance concrete, precast concrete, and the latest technologies like self healing concrete and 3D printing concrete. Why do we have self healing concrete? Because that is in respect to the maintenance and repair work. So if your concrete is, again, the cracking is inevitable in your concrete. So if it gets cracked, so we are making the concrete as self sustainable so that it can heal on its own by providing some products that would fill up the cracks that will be developed, and then it can be healed on its own by filling the cracks. And then 3D printing concrete, so we don't need to wait for the concrete to be mixed and placed and wait for the strength gain. So it's all about you pour the material and it will be printed to the required dimensions. So a lot of research is being on going focusing on these topics. And then reinforcement, when we talk about the reinforcement, we'll have conventional steel rebars and then coated steel rebars. Then you have FRP bars in strands and pre-stressing strands, right? So I'm not touching about the normal concrete. So it's about the materials that we use. I'll just directly get into high performance concrete. So when we talk about high performance concrete, we'll be using some supplementary cementitious materials which will help us to enhance the strength as well as the durability. So why do we use such materials that will help you to densely pack the aggregates, so that there is what something called pozzolanic reactivity, pozzolanic reaction. So these materials in general have some reactive silica or alumina, so that when it get in contact with shame hydroxide in the presence of water, that produces additional csh gel. So that csh gel will help you to enhance the strength, and that product will help you to fill up the additional pores. And the final materials of these ACMs will also act as fillers that also act as a fillers, so that your matrix will be much denser. So that's why the densing packing of aggregates will be achieved, and low water cement ratio can be used for meeting the high performance concrete, and proper curing need to be done. So proper curing, why? To avoid the early cracking due to shrinkage and thermal stresses. And here you can see various types of um, SCMs listed, fly ash you can see, and then you have GGBS, ISS hash, and silica fume, and metakaolin, and you have fine POFA material. So when you talk about the ultra high performance concrete, here you are limiting the coarse aggregate. So coarse aggregate will be very less. The size of the coarse aggregate is limited. So it becomes too fine at the material. So ultra high performance is defined as a cementitious based composite material with discontinuous fiber reinforcement, and generally the compressive strength of the material will be above 120 MPa, and it will have pre and post cracking tensile strength of above 10 MPa, and this will also help you to enhance the durability. So you can see some steel fibers used in this purpose. You can see the ultra high performance is shown here. So you will be having some cements and porcelains, and you can have some fine aggregates, fine sand coast ground quartz and fibers. High range water reducer is required because you're talking about 120 MPa. That means the water cement ratio will be very less, and you'll have some fibers also. So in case if there is any cracking, and this fibers will help you to enhance the toughness of the material. Why? When we go with this 120 MPa strength, basically you are making some material which is very brittle. So when you have brittle material, so the failure will be sudden. So to enhance the toughness or the energy absorption of the material before it fails, we will be adding some amount of fibers. That's why we use some fibers to enhance its durability. So when you talk about the performance of ultra high performance concrete, so you can see this is a control mix, and you have a high performance concrete, and this is the range of 80 MPa. This is about 200 MPa. The compressive strength is significantly high for this RPC, basically indicates reactive powder concrete. So which is the one form of this ultra high performance concrete. The fracture toughness is also significantly high. So when we check the application of this high performance abrasive wear, because it has very good strength and toughness. So the abrasive wear will be about 2.5 times lower than your conventional concrete. And water absorption, because these are two finer materials, the pores will be very less and you have a tensor matrix. So the water absorption will be 7 times lower and rate of corrosion will be 8 times lower, and chloride ion diffusion will be about 25 times lower than your conventional concrete. And let us consider the increase in toughness due to bridging action of the fibers. So I was talking about this post big behavior. So this is the region which will help you to meet the or give the warning before the material is going to fail. So the why it is important, because once it has reached its maximum capacity it is going to fail, but you don't need to have the failure as sudden failure. Okay, so the material has to deform or show some sign before it fails. So that is what we call the area under this entire curve, it is called toughness. So toughness is the ability of your material to observe energy before it fails. So as the energy is more, the failure will be delayed. So we want to have the post peak behavior as much as possible, basically indicate amount of energy absorbed before it fails. So this again varies in various different standards. So this is basically the curve with respect to the load versus deflection. So the entire area indicates the toughness of your material. So when we work with the fiber reinforced concrete, we basically check how much the material can absorb before it fails, because your concrete is a quasi brittle material. It cannot absorb more energy before its failure like the steel. So steel tend to bend, deform, right? But the concrete cracks again as the strength is increasing. It becomes too brittle and then it is like a glass. It will be like, but failure will be occur. So we don't want to have sudden failure. That's why we add fibers in it and enhance the toughness of the material to achieve the form. So that is with respect to the ultra high performance concrete. And then we have self healing concrete. So self healing concrete, as the name indicates, it's a self repairing concrete itself. You have a concrete composite with the ability to repair small cracks automatically without any external diagnosis. So how does the mechanism occur? It is autogeneous healing. How? The cementitious material, that is further hydration of unhydrated cement in concrete. So the concrete has cement, moisture, and aggregates. So when we have the concrete, it doesn't mean that all the cement in the concrete has hydrated. There will be some unhydrated cement present in your concrete, and that could be, get be accessible as your crack is occurred. So that if that gets in contact with the moisture or some agents which helps to trigger its reaction, that is going to react and produce additional CSHL to fill up the cracks. So that is what we are talking about here. For the hydration of unhydrated, such unhydrated cement in concrete will help you to achieve healing. So mineral admixtures, fibers, nanofillers, and curing agents are such helping agents for you to meet this autogeneous healing. And the second one is autonomous healing. So that is a trigger that is required to activate this process. So for this autogeneous healing, you don't need to do anything. As long as you have a mineral admixture in it, as long as you have a fibers or some curing agents in it. So once it is cracked, that is going to get react and that is going to fill up the gap. So when you have autonomous healing, so you have something there already, but it requires some additional trigger from the outside, right, to activate the process. So that could be embedded unconventional engineered additions. So this is not like your unhydrated cement that you have the potential to react and react. So provide something. So this embedded and unconventional engineered additions that reacts and that helps you to repair large scale cracks. I will show you in the next image how this healing works, the mechanism of these healings. So this kind of materials capable of repairing cracks within a few hundreds of micrometers, meaning structural damage cannot be repaired. So these type of materials will be helpful to no heal only the initial stages of the repair. No, especially the issues related to durability, so exposure conditions and all. If the structural damage, if you have a huge or wide cracks, then this is not going to help you. So as long as the crack width is minimal and narrow, and this kind of material will help you to prevent such cracks to grow further and to enhance the crack width propagation. So here you can see the mechanism of homogeneous healing. You have a concrete structure and with a crack, and this could be physical cause where you have a swelling, and if you have a chemical cause where you have a continued hydration, and sometimes you may have calcium carbonate formations, but the mechanical causes will be you'll have fine particles and broken of you can see the broken pieces here, and you can see here in the water, originally in the water. So this broken pieces will be on out, it's a mechanical causes, and then the chemical causes, then it will continue to hydrate, and then you can see swelling, and then the swelling will help you to bridge or fill the gap. And here you can see the performance of healing materials in self-healing concrete. You have a concrete with mineral admixtures. So here you can see the crack after damage is induced. And now you have expansive agents to fill up the gaps in the form of geomaterials that will get swell and fill the gaps, or the carbonate precipitates. So when you have water to be filled in this, then the carbonate precipitates will get fill the cracks. So now after filling, you can see the expansive gel agents, geomaterials, carbonates eventually fill the cracks. So here those are started to react, and here you can see the filled cracks. When you look at the images in the longitudinal view, so you can see damaged ECC with crack widths less than 60 micrometer, which all healed by the healing products, which has filled the gaps or the cracks when exposed to water or air. So lesser size of cracks means lesser amount of healing materials, which in turn lead to higher healing efficiency. So that's why this is not appropriate for structural cracks. So if the crack width is in the initial stage, then this type of materials will help you to enhance the performance the early stage of your structure itself. And then next we have something called 3D printing concrete. And I don't know how many of you know about TASWA. It's a startup by IIT Madras under the IIT Madras company. So they are doing enormous work on 3D printing concrete, and recently they have inaugurated a 3D printing tower that was constructed by them. So this technology is all developed in 1980s. Stereolithography and fused disposition has prevailed over 1980s, but was not popular for the construction industry. So this was developed in for for stereolithography. So in medical field, they started using it. So the pioneering work by Keshnevis et al. Called countercrafting revealed the potentials of additive manufacturing technology in construction field in late, early 2000s. And then most popular method is that you extrude the material. Extrusion based 3D printing was done, and here the cementitious materials was deposited as a layer continuous filaments through a nozzle in form of layers. So you have a nozzle and you have all the cementitious composite in it, and then you just print it. That's how it was started. And in 2014, Winsu, Chinese construction company, printed two-story buildings successfully. And then it got attention across the globe, and lot of research groups started working on it. How does the material works? How can we enhance its potential to fabricate or to print a huge structures? So, additive manufacturing or rapid prototyping is a process of creating complex geometrical elements from computer models. So, you feed your model in the computer, and then you connect it and program it to the housing structures, and then it will be printed. So, might be seen some a lot of small unit print 3D printing materials, toys or pipes. So, it's been used in various industries, and it has its potential in our construction industry as well. So why do we use it? The advantage of this, it will increase the geometrical freedom. You can pretty much do anything with this, any shape that you want to do it, and reduction in human labor and cost and time, and has low risk, etc. So you can see the amount of cost that we invest in labor, and then the material cost and concrete material cost and concrete labor cost. So 7 plus 53% is or about 60 percentage is about the labor cost, and then rest 40 is about your concrete and then material cost for the form work. So the material cost for the form work is about 10%, So we can pretty much cut down the price significantly to 70% when you go with this 3D printing concrete. How does it work? The material behavior. When you look at the material behavior, you basically work with the rheological property of the concrete. So your concrete has to be as flowable as possible, but at the same time, once it is placed, it should have its stability. So that means the care should be given enough that the flowability should stay as it is with proper stability once it is being placed on a position. So the research shown a correlation between pumping behavior and then rheological properties through Kaplan model. And then the pumping behavior of concrete is also dependent on the discharge rate. So at what rate you are discharging your material from the nozzle to be printed on the required shape, and then the pipe diameter and length of the pipe hose. Those are all going to govern the stability part of view. But once the fresh concrete reaches the nozzle head, it contracts due to the nozzle based on its shape and size, and then you can see a layer is being deposited one after one over the other occurs the desired shape. So it is not a complete shape in one go. So it is like you will be moving with layer and layer. So I will show one image of such 3D printed concrete structures how it looks, and then you need to do some surface finishing to enhance its aesthetic look further. So there are chances of liquid phases separation. So that's what I was talking about when we are talking about the rheology. The mix should be as homogeneous as possible, that liquid phase should not get separated from the concrete due to sudden contraction and subsequent extrusion occurring at the nozzle. This liquid phase separation would result in increased frictional force and would induce high extrusion pressure, and that is going to affect the filament, and then you may see a lot of surface defects, and that is going to even affect the flow session. So how can you manage all the challenges associated with this flowability or the liquid phase separations while it is being placed? So by adding some additives like cellulose ether and calcined clays, which improves or helps you to achieve the water retention, and this helps you to reduce the segregations that you may be facing during the liquid phase separation. So external vibration at the nose is another alternative to avoid such issues. I talk about, and then you may need to look at importance to yield stress and viscosity that should be low during pumping, while immediately after deposition the yield stress should be of higher magnitude. So it is a paradox. So while pumping the yield stress has to be lower and viscosity has to be lower so that it can be easily moved or placed, but after placing the same thing should be enhanced so that it can maintain its stability. So this is achieved by additives and nozzles which can cause increase in yield. So what do you do? So in the pump, you make the material to have lower yield stress at the end of the pump, or when it is coming out from the nozzle, you add some additives which will help to increase the yield stress and elastic modulus. So you can also have some accelerators. So calcium sulfoaluminate cement can be added, and you can have thixotropic agents like nanoclay may increase the rates of structural buildup through an increase in the flocculation of cement grains. So those are some additives that help you to enhance the rate of structural buildup. So that will help you to increase the um, flowability or the placement of your layers. The most common method for assessing extrudability is based on printing a filamental layer of a given length and then visually examining for signage of blockage and tears or discontinuity. So it means like you'll be having a layers placed one over the other, and visually examine that the layers are being placed properly, or is there any signs of tears or damages while it is being placed. And then buildability is measured by the number of layers until failure or based on the deformation of the printed layers. And you need to buildability rate, find a buildability rate so that there is no significant deformation. So then once the buildability rate is achieved, you wait for the layers to gain the strength so that the additional levels can be increased. So uniaxial confined compression test or triaxial compression test, or a direct shear test, or some NDT test like ultrasound velocity, to measure the evaluation of the material properties such as compressive strength and Young's modulus can be used. So you can see this is one such structure that is shown with using this technology in IIT Madras by Tasva startup company. So this was a very basic structure that was tried by the team. So it basically model just a small sections by the, you can see layer formations here clearly, and here you can see a small house is built up using this technology, and after finishing and painting how beautifully it looks. So still you can see the layers, and then there. So overall, this is a promising technology for the future, and it helps you to achieve any dimensional requirements, and it helps you to cut down the cost, the construction cost by 30 percentage when it is being successfully implemented. So this all with the concrete. So I'll just quickly move touch up the aspects that we look for the reinforcement. When we talk about the reinforcement, we mostly deal with TMT bars, right? So initially we were working with mild steel, and then we evolved to CTD bars because the mild steel is not giving, you know so the strength that is being offered by the mild steel, that is 250, if you FI 250 is not adequate, so we have raised our bar to CTT bars where you can enhance the yield stress beyond 450 or 500. But later we have observed that CTT bars are not adequate enough for meeting the durability performance, because CTT bar is, as the name indicates, you have 12 twisted bars, and that will have high reactivity, and when that gets a chance, that reacts faster and results in early corrosion. That's why we nowadays we don't have CTT bars as common as your TNT bars. So that's why we aspects. So the name indicates it is being thermomechanically treated, or you can say quenched or self-tempered QST bars. So you can see here the process of TMT bar manufacturing. The surface will be granite and core will be austenite. So once it is being taken to the quenching box, so you can initially, the temperature will be very high in the range of about 1000 degrees Celsius, and it will be quenched. So when it is being quenched, so the outer surface becomes martensite, and still this inner surface will be in austenite mode. So after quenching, what happens then? The temperature now will be transfer from the surface to the inner. So you will be observing tempering phases. You can see here you have the surface, so surface temperature will be increased, so your surface becomes as tempered martensite, but still your core will remain as the austenite. And then you have a cooling bed, and then in your cooling bed, both this material temperature will be reduced further. So is after 50 minutes, or even that will be kept for more than about 3 hours. So in that case, your inner core becomes ferrite and perlite. So you'll be having tempered martensite at the outside and inner ferrite and perlite. So here the point to note is that the outer surface helps you to achieve and the other will be contributing to the ductility. So the outer surface is basically responsible for the strength. So tempered martensite will give you strength, and then inner core will give you the quality. So how do we check the quality of weight, load, and ductility at the last case. So what we did is like we have compared various bars available in India. So you can see the ranges from 8 to 16. So this will be used for the stirrups. So where you may need to bend your rebar also. So if the core outer ring and uniform is not no outer ring and then core is not uniform, then while bending you may also observe cracking, especially when it is being used as a stirrup. Secondly, as the diameter increases, there is no, the uniformity in the outer ring is better compared to the lower diameter. In lower diameter, you see the uniformity in the outer ring is worse in most cases, but for the same brand, as the diameter increases, the uniformity is better with the bigger diameter. So what we do, so those smaller diameters are the ones that would be used at this depth. So if it is not being done properly and while bending, it may observe cracking, right? So if you have a uniform outer ring and then core, then while bending there will not be any crack. If you don't have a uniform outer cracking and while bending, these are the regions that will be prone to the cracking, right? Because there is no temper martensen to provide required strength. So there is the IS specifications tells that when you do such quality check, you may also need to bend the rebar at 135-degree angle and see whether the stirrup is cracking or not. So if it cracks, you disqualify. If not, you can proceed with the material. So must check the surface I don't know why my slide got screen got disconnected. I have shared it again, and I'll address the questions at the end of the talk. So we have 10 more minutes to go. So here you can see the bend test, was specified by IS 1608. You have a mandrel diameter to bend your rebar and see where is it going to crack or not. So that is with respect to the conventional reinforcement, and to enhance the corrosion properties, we also have fusion bonded epoxy coated bars. So as the name indicates, your epoxy will be coated on the top of your steel rebar, and then when you place the rebar in the concrete, this is how it is going to look at your steel, and then you will be having a coating, and then you have your surrounding concrete material. Right. So what are the protection mechanism here? So the assumption is that when you coat your steel, you're basically eliminating the direct contact between the metal and the electrolyte. And when the coating is there, you're basically reducing the driving potential that is going to induce corrosion, and you're basically reducing the oxygen supply also. But if the coating is not done, then the scenario is going to be worsen here. So you can see the process of FB coated rebars. First you have the plain rebars, so you'll be surface cleaning it, and then you prepare the surface for the epoxy coating on top of it, and then epoxy resin will be powder, and that will be placed on the steel surface. Then you will be water quenching it and resulting in thermosetting polymers. Then you inspect for holidays or damages, and then you allow the material to go. So what is holidays and pinholes? So if the coating is not done, if there is any pinholes or something that is present, and that is what we call it as holiday. So we check with the wet sponges and wires to see whether your material has pinholes or holidays. If so, you can see here that will get in, and that indicates the thing, and the potential will also be higher when you have pinholes, resulting in a higher corrosion rate compared to your conventional concrete. So the additional inside, how do we do? So typically, when you deal with this epoxy coated rebars, once it is coated, it should not be bent. But unfortunately, in these sites, they bent it for preparing stirrups. So in other developed countries, how do they do? They bend the bars if the disc has to be used as a stirrup. They'll bend it first, and then they will be coating it so that the coating will not be damaged when it has to be used as stirrup. So rebar should not be cut at the side, or it should not be bent at the side. Even if it is cut or bent, it will be just, you just pour additional coating to fix it. But this is not going to serve the purpose, and this is going to worsen. So as the thickness increases, the coating efficiency becomes less, and that may deteriorate and leading to other damages. All right. So you can see here the fusion bonding will not occur at ambient temperature conditions, and this should not be cut at the site, and it has to be thoroughly checked for any surface damages. And here is an examples where you can see the such rebars are being cut and bent at the site, and while it is being done, the coating will be get damaged. You can see here the coater got damaged, and a lot of cracks were observed on the top of the coating. So here you can see the service life predictions with respect to FBE bars. So when you use the FBE bars properly, it will help you to. You can see this one is the conventional rebar without any coating, and here another point to notice is these epoxy bars are tend to degrade when it is being exposed under the sunlight for direct sun for longer duration. So this ND basically is no damage, and UV basically represents ultraviolet rays, and SD represents direct sun direct. So if you have properly use this technology, this will help you to enhance the service life. If not, this may even surface damage. So this ND is no damaged case. So in no damaged case, the probability of failure will be lesser compared to your conventional reinforced concrete, and that will help you to enhance the service life of about 120 years. Whereas if you look at the ultra wide or surface damage, you can see the probability of failure is very high compared to your conventional concrete systems. So that means if you can take a good care of the coating, then this technology will be helpful for you to enhance the service life. If not, this is going to worsen the performance of your structure by increasing the probability of failure and thus reducing the serviceability of your structure. And you can see the premature corrosion observed in such cases due to moisture attack without even chlorides. So you can see there is no coating at all. The coating has come out, and how severe the corrosions are at this place. So it is more dangerous to use damaged epoxy coated steel than the conventional uncoated steel. So that's why the saying says that if you can give a proper care, go with it. If not, then it is better to go with the uncoated bars than using the coated bars. And then we have this FRP bars in practice. So for that, all you need is use this fibers, and it's a composite material, so fiber matrix in the resin, and you will be getting a FRP composite. So in terms of glass and basalt fibers we have in practice, and we are gonna also have carbon fibers to be used. So this will help you to reduce the weight of your rebars and then enhance the corrosion resistance, because you all know steel is prone to corrosion, right, when it is being exposed to environmental aggressive environmental condition. So in such cases, these kind of FRP bars would be helpful, because this is non-conductive to electricity and heat, and it is brittle in nature, a non-metallic corrosion, and this can give you long-term performance in a high alkaline marine environment. And alkali resistance fibers must be used when it has to be. So this is a comparison with respect to various bridge types of rebars that we have, and then the cost ratio. So you may need to spend initial cost when you go with the fiber reinforced polymers or galvanized steel materials. So the cost ratio will be initially high, but when you look at overall life cycle cost of the structure, it will be much lesser compared to the conventional materials or other materials which will give you lower cost. Why? Because when you use such materials, that will help you to reduce the maintenance work or the repair work that need to be done in the pose in future conditions, right? Whereas other materials may lead to a lot of repair work in between, and which will result in higher life cycle cost. So depending on the importance of the structure, you choose a material. Though it gives the initial cost high, this will help you to reduce the overall life cycle cost of your structures, looking at the sustainability point of view. All right. So I'm just stopping it here, and I'll have discussion for the next 5 minutes. I also have some couple of things about the pre-tension concrete systems, but I'm not going to touch that as we are limited to the time, and we are done. So I hope the informations are useful for you to connect the details that you have already know with respect to the materials aspect, how it will help you to achieve the structural properties, structural performance, looking at the serviceability of your structure.
Thank you, ma'am. Can we have a small question and answer session, ma'am?
Yeah, sure.
Dear participants, if any of you have any questions, you can unmute yourself and
So,
ask. Parallelly, you can also type it in the chat box.
Good afternoon, everyone. Good afternoon, everyone. Any questions you can ask? Thank you so much, ma'am. So
Thank you, Anita.
on behalf of our management and principal, HOD of Sir MVIT Civil Engineering Department, and all our faculty team, I take this opportunity to express our profuse gratitude and sincere thanks for your valuable thoughts expressed in this occasion. Definitely, it will help our participants to apply in their respective areas of work. Thank you so much, ma'am.
Thank you.
Finally, I solicit your continued support and encouragement to move forward for the quest of our knowledge. Thank you once again, ma'am. Thank you all.
Sure, I look forward to. Thank you.
Yeah.
Thank you
Yeah.
for having me.
Thank you, madam. I just, on behalf of I, Ravi Kumar H,
Yes, sir.
participants kindly fill up the feedback forums. And on behalf of management of Sir MVIT and Civil Department, I thank Dr. Prabha, guest speaker of this session. Also, I would like to thank our colleague Tamil Semi for the successful conduction of this session. I thank all the participants for their active participation in this session. Now we shall break. Let us join at 2 p.m. for the second session on virtual construction. So before going, please fill up your feedback forums.
Thank you.
Thank you. Thanks a lot, madam.
Thank you, sir.